All right, number 9. This one we also want to do the full hypothesis test. We are given just the word, I guess the layman's terms of what it means to reject HO or fail to reject HO. And so I don't have these memorized, but I have to go through the testing and then I'll be able to explain it once we do the testing. But we have engineer has designed a valve to regulate pressure. It was tested on 190 engines. Okay, so this is number 9. We have a sample size of 190. The mean pressure, so the sample mean from this sample was 6.4. Population variance is 0.64, so sigma squared is equal to 0.64. That means that sigma is equal to 0.08. Okay. So this is the value we actually want. And it says it was designed to produce a mean of 6.3. So the true mean is 6.3. And it says, is there sufficient evidence at the 10% level that the valve does not perform to specification? So it just says does not perform. So that means either equal to or not equal to. So setting up my null and alternative, I'm going to move this, but let's do it here. Null and alternative. The mean is equal to 6, or not equal to, sorry, 6.3. And then up here the mean is equal to 6.3. So this is a true mean. We're going to have a two-sided test. So we're going to find that critical value. So that 10% alpha is equal to 10%, 0.1. And so from there, we'll go to the table, find the critical value. We can go to critical. We want 10% right here. And we want two-sided, so 1.645. So we have negative 1.645. And we have positive 1.645. So here's how we read this. If it falls in any one of these spaces, we reject HO, which means there is enough evidence to support the claim that they're not equal. So we're in favor of this. So if we reject HO, then we're in favor of this option. There's enough evidence to say that it's not equal to. And then if we fail to reject HO, so if it falls in here, then we say that there's not enough evidence to support that claim. So what we're doing when we set these up, this is what we believe to be true, but we assume that this is true, and we're testing to see, is it actually the case that they could be equal? And so we're coming up with some values that are really, really extreme on the high end and low end. That's much too high and much too low for us to say that these guys are equal. And if they fall here, then we say that, okay, this is not the case. They definitely cannot be equal because this is too high or this is too low. And if it falls maybe somewhere in the middle, it might be a little bit higher than the mean, or it might be a little bit lower than the mean, but it's not too extreme. It could be just to some type of error in the machine, or in the sample that we got. There's a number of things that could affect it, but we're coming up with some extreme numbers to either completely rule out this, or if it's not extreme enough, then we say, okay, this is the case. We can't reject it. So rejecting this leads to us being in favor of this, which is the second scenario. It says there is sufficient evidence to support that they're not equal because it's too large, or we fail to reject it, which means there's not enough evidence. Okay, so I'm going to do the test. I'm going to just do the test statistic in this blank space here. We have our sample mean of 6.4, subtracting 6.3, divided by the standard deviation of 0.08, divided by the square root of the sample size, which is 190. And it's going to give me a value. Open parentheses. We're going to do 6.4 minus 6.3, close divided by open parentheses, and then we're going to do 0.08 divided by the square root of 190 and close. Okay, so we get, oh, this is a really big number. That looks okay. Let me just verify that I got my standard deviation correct. So 17 is what I got. Second square root 0.64. Oh, it's 0.8. So I got the wrong number in here. Okay, that's why it's so big. It did look strange. This should be 0.8, not 0.08. Okay, so I'm going to just change that really quick. I'm going to arrow back to this problem and delete it to 0. Okay, so I should have had a 0.8 here. Usually if I get something this big, I want to double check, because our normal table, let me just pull it up, only goes from 0 up to like 3.4, 3.5. So when I get something really, really big, 5, 6, 7, something much, much bigger, then you always want to double check. It's not impossible for something like that to happen, but it's just not the norm. So that's what made me want to go back and double check, but here we go. Okay, so this is much more manageable, 1.72. Okay, so that's all I need. I don't actually have to go and find the area. 1.72 is going to be over here. Okay, bigger than 1.6. Okay, this is 1.7. Okay, this is in the rejection area, which means we are rejecting this and saying that, hey, it is true that these, our test is saying that they're not equal to 6.3. This is too big for this sample. So we're going to say there is enough evidence to support the claim that the valve does not perform to specification.